Well, good afternoon, everyone, and welcome to another Sun Devil Learning Lab session. My name is Michael Barker. I'm your instructor today from Arizona State University, and we're going to move into adding fractions. We'll just remember a little bit about what fractions are. We were parts of a whole. Here we have a whole, we have parts here, and we also have parts, let me see here, I'm going to switch and get a better pointer for us. Here we go. We also have parts of a whole on the number line. Now our introductory slide here only shows up to one part, one whole. We're going to see as we go forward that we can have a situation where we have more than one whole, but we can still express that as a fraction. Now, before we start working on adding fractions, there's a few things I want you to remember. It's our usual rules and policies with my lessons. First, and probably foremost, make sure that you're in a comfortable setting. No distractions. What you want to remember is that if a brother or sister is running around or the TV's on, you want to shut all that stuff down. Ask mom or dad if they can keep your sister or brother away, or if there's a quiet place where you can work and focus. It'll actually help you because maybe you won't have to stop the video so many times as to try and get through the lesson. Secondly, let's gather any supplies you might need today. I'm going to suggest a couple of pencils, a notebook, at least several sheets of paper if you don't have a notebook, scissors maybe if you want to make some fraction bars, and definitely a ruler because we're always drawing a lot of straight lines for number lines and whatever other shapes we may need to draw. And a ruler just helps us keep things a little bit neat. And finally, be sure and use the restroom before we start. And remember that you can always pause the video if you need to take a break. Adding fractions. Let's review. This is some stuff that we should already know as we've been going through our lessons, but we'll double check and just make sure. So I've got this little primer here. 1/3 plus what fraction is going to give us what fraction that equals 1. Another one is 3/7 plus what fraction equals what fractions equals 1. Two more, 3/8 plus a fraction, 1, and 2/10. I'm going to pause the video for a minute now, and when I do, you'll be able to take 3 minutes and see what you get when you look at this. Okay, we're back. This is what your solution set should have looked something like. We asked what was 1/3, what did we have to add to 1/3 to get our whole one, which would be 2/3, a total of 3/3, and that's 3/3 is the same as one whole, 3 parts of 3. Second problem was 3/7, and we should add 4/7. 3 plus 4 is going to give us 7/7. 7/7 is the same as one whole. Over on the right, we had 3/8 plus what? 3 plus 5 is going to give us 8. 8/8 is one whole. And finally, we're looking at 2/10. 2 plus 8 gives us 10. 10/10 is going to give us one whole. And now that we've looked at that, let's look at our first problem today. We'll give a sample problem adding fractions. I'll read, or you can read along with me. Leslie has 1 liter of milk in a refrigerator to drink today, so that would be our whole. She drank half a liter of the milk for breakfast and 2/5 of a liter of milk for lunch. How much of a liter did Leslie drink during breakfast and lunch together? So they're going to ask us to add this fraction and this fraction, or this fraction and this fraction. And we're going to look at that, and we can see that we really can't add that because the parts weren't equal. We couldn't add those parts the way they were. I'll go back to that slide for a minute and show you that because these aren't the same size, we have to wait, or we have to figure out a way to work with units that are the same size. And so as we go back to our problem now, what Leslie did was she had that 1 liter of milk, and we need to break our units into equal parts. We worked with, in other sessions, we've talked about lowest common multiples, or we just want to look at our unit and see what can we break it into that would, each of our pictures would have the same amount of units that we can count and divide our milk into. And what we wound up with was 2 and 5 is 10. So we need to break our unit into 10 equal parts. And that's what we've done here. We took our whole, and if you want to count with me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 parts. Now again, here our half of 10 is going to be half of that. So we know 1, 2, 3, 4, 5, and then another 5, 1, 2, 3, 4, 5, and we now have our 10, or our half, which is 5 out of 10. And now we'll look here, we have 1, 2, well, let's count our 2/5. This was our 2/5 drawing, and so we have 1, 2, 3, 4. And we'll see that in our next slide when we looked at how much milk she drank. 5/10 is going to be equivalent to our 1/2 unit. And 4/10 is going to be equivalent to our 2/5 unit. We should be able to see all that illustrated because we still have a total of, in both boxes, I'll count again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've just kind of shifted the problem into counting units of 10. So now what we have to look at is, what we're working on here is 5/10 and 4/10. And what is our total going to be? Well, we already know that our whole is going to be 10, right? Because we're just counting that's the total number of parts in our whole unit. We want to know now the number of parts combined in each part. So we had 5/10, 1, 2, 3, 4, 5. And we had 4/10, 1, 2, 3, 4. 5 plus 4 will give us a grand total of 9/10. Now we might have to look at the problem one step further because they may ask us. So if we go back, it said, Leslie, 1 liter of milk in a refrigerator to drink today. So can we see that Leslie will only have 1/10 of a liter of milk left for dinner? Because she had a total of 10/10, and then she drank 5/10 and 4/10, which gave us a grand total. Well, I can't say, we hid it behind the screen here. I'm trying to get my slide back. But 5/10 and 4/10, 9/10 leaves 1/10 for Leslie to drink with her dinner. So now we'll move into another thing about adding fractions, and it's we're going to look at 2 different sample problems. The first one will be 1/3, and the second one is 1/4. 1/3 plus 1/4, and then our second problem will be 1/2 plus 3/4. And take a second. We've learned a little bit about our fractions, and is there anything you notice about these 2 expressions? Think about them maybe in relationship to how they would be if you were going to compare them to a whole. I'll tell you what, take 1 minute and then we'll come back and see if your thoughts are the same as mine. And we're back. And so now what I asked you to look at is to see what you could tell me about these 2 expressions. And I hoped you could tell me something that both in the first one, both fractions are less than 1/2. So when we add 2 parts smaller than 1/2, we should wind up with a fraction that's still going to be less than a whole. When you take 2 parts smaller than 1/2, our answer is going to be less than 1 whole. But on the flip side, this fraction, 1/2, is equal to 1/2, or 3/4 greater than 1/2. When you add 2 fractions greater than or equal to 1/2, our solution will be greater than 1. We have a greater than mark here. We can kind of see it here because when we add 1/4 and 1/3, this area here is still less than 1/2, okay? But now when we add 1/2, which is all of this, and we add all of this, I hope you would see that putting those two pieces together is going to be greater than the whole. So we're going to try and solve now. We'll solve using our area models. So what I did was I broke both of these into area models, and then we'll work on the problem on the right first. But here we took 1/3, turned 1 unit, 1 whole, and broke it into 3 parts. We took another equal size unit, and we broke it into 4 parts. 1, 2, 3, 4. Now the problem we're going to focus on first, we took 1/2 and 3/4, 1, 2, 3, 4. And we want to add those together. So let's see what we did. Well, my solution was, since we already knew that we had 4 parts here, 1, 2, 3, 4, we wanted to know if we could turn our halves into 4 equal parts. And that was pretty easy to do. We just divided this half and this half, and we now had 1, 2, 3, 4 parts to compare with 1, 2, 3, 4 parts. What we did next was count 1, 2, 2/4, the same as 1/2, plus 3/4, 1, 2, 3/4, gave us a grand total. 2 plus 3 gave us a grand total of 5/4. If we look a little further into that, we could take one of our fourths, and what we want to do now is we'll put it over there to give us a whole unit. We now have 4/4, 1, 2, 3, 4, leaving us 1/4 at the original part of the problem. And what this is going to do is let us go from an improper fraction, 5/4, where our numerator, the top number, is greater than our denominator, the number of parts. So this is the denominator is the number of parts in one of our wholes. The numerator is the number of parts we're actually counting. So as we go back, we now have 1 out of 4 plus 4 out of 4 gives us 5/4. And if we want to look at it another way, we have 1/4 plus 1, because our 4/4 is the same as 1 whole unit. So then when we write it as a mixed number, we write it as 1, and we have to add in whatever our fraction is. We have 1 and 1/4. I hope that makes sense. We're going to move back to our other problem now, and that's going to be adding the smaller fractions that are less than 1. We're going to have 1/3 plus 1/4 are going to be less than 1. And we'll solve again using our area models. And this is going to be a little bit different. We have our 1 unit and another whole unit. And we drew that first we drew it into thirds. I think we went back, and I can look at that. We have our thirds here. We have 1/3, 1, 2, 3. And this is our unit where we have 1, 2, 3, and 4 parts. So we want to divide them into equal parts. So if we draw in our 1/3 line, if we take and draw 1, 2, 3 lines and divide the section by 4, we now have a total of 12 squares. And by the same token, if we take our 1/4 line, and it's broken into fourths, if we then draw 2 lines and draw into 1/3 sections going across, we now still have a total of 4. 1, 2, 3, 4 times 3. 4 times 3 is 12. You may also be able to know that when we look at 3 and 4, we know that our denominator is going to need to be a number that both of these can be divided by, or what can we multiply? So that what's the lowest common multiple for these solutions? Well, 3 times 4 is going to give us 12. And 4 times 3 is going to give us 12. So when we look at our illustration in that sense, now we know that 4 twelfths, 1, 2, 3, 4, the same as 1/3, added to 3 twelfths, 1, 2, 3, is going to give us a total of 7 twelfths. What do we know about that? Is that we've now taken 1/3 and 1/4, and we've changed them into versions that have common denominators, the same number of parts in a whole, and that allows us to add unlike fractions. And in this situation, 4 twelfths plus 3 twelfths will give us 7 twelfths. I'm going to pause now. I've got a worksheet here. It's a practice sheet, and it's going to take you a few more minutes to do this one. Take 10 minutes and see what it takes. Use area models and add the fractions together in each of these expressions. Okay, we're back finally for the, let's look at our solution sheet. Hopefully, your solutions will look something like this. We've look at our first problem, 2/3 plus 1/2. We can draw an area model with 1 line and 2 lines, and we have 2 parts of 3. And then we can draw another one where we drew in 1/2. So now we need to divide these into the same number of parts that we can add. And how do we do that? Well, we could draw a line down the middle of this unit, and that'll give us 6 equal parts. And we can draw another 2 horizontal lines here, or vertical lines, I'm sorry, and that'll give us 6 equal parts. So now we can count parts and what we have shaded. In the first one, we have 1, 2, 3, 4 out of 6 shaded parts. In the second one, you should have 1, 2, 3 out of 6 shaded parts. And that's going to give us a grand total of 4 plus 3 will give us 7/6. That's our improper fraction. If you change it to a mixed number, you should be able to determine that 6/6 is going to be a whole, and you're going to have 1/6 left over. Let's look at our next problem. 3/4 plus 2/5. Well, this isn't going to divide up quite as easily as some of the other problems we've done. But if we look at 4 and 5, what would be a multiple that's the same? Well, it's not going to be 8. It's not going to be 10. 3 times 4 is 12. 3 times 5 is 15. It's not going to work. 16. How about 20? We can divide both of our parts. 4 times 5 is 20. 5 times 4 is 20. We can divide both of our wholes into 20 equal parts. So once we've drawn our 1, 2, 3/4, we use 5 lines. We divide it into 5 sections with 4 lines. I'm sorry, 1, 2, 3, 4. And we now have 20 squares. 15 are shaded. And when we look at the other side, we divide it into, we draw 3 lines, 1, 2, 3, and we wind up with a total of 8 shaded squares out of 20. So now we know we just have to count the shaded parts. 15 shaded parts plus 8 shaded parts out of 20 will give us 23 shaded parts out of 20, or 1 3/20. So 3/4 plus 2/5 will equal 1 3/20. Next problem, 1/2 plus 3/5. Again, we broke our whole. We should have done something that looked like this, 1/2. And then you should have drawn your second part into something that had 5 parts. I usually draw horizontal first, 1, 2, 3, 4, 5, and we shade 3. And then we have to remember that we need to make it into more parts that are the same that we can count. So 2 and 5, we learned that in an earlier problem that we're going to be able to have to cut our whole units into 10 equal parts. 2 times 5 will give us 10. So when we divide 1/2 into 10 sections, we have 1, 2, 3, 4, 5 tenths. And when we divide 3/5 into 10 sections, we have 1, 2, 3, 4, 5, 6. 6/5, 6/10, I'm sorry, and 5/10 will give us a grand total of 11/10. 10/10 is 1, and it leaves us 1/10 extra. So our mixed number would be 1 and 1/10. Moving right along, we'll look at 5/7 plus 1/2. Again, you may have a little bit of trouble figuring out our units. We can always multiply the two denominators and see if that number works for us. It always will, but sometimes there's a smaller number. But in this case, 2 times 7 is 14, and that's what our number is going to be. So first, we want to divide our box into 7. You should have drawn 7 equal parts here. And then we need to cut them in half again. So we draw a line down the middle, and we now have 14 parts. And we have shaded 5 out of 7, or 10 out of 14. So second part, you drew a half, and now we need to divide that into 14 parts. So we're going to need to divide the whole box into 7 equal parts. So we draw our lines, and we wind up with 7 out of 14, which gives us a total of 17 parts out of 14. Again, 14 out of 14 will be our whole, and that'll leave us 3/14 left. You should have had something that looked like this. Your pictures can look different, but at the end of the day, your mixed number should look like this, or like this, and your improper fraction should look like this. Okay, we got 2 left, 3/4 plus 5/6. Same thing, we'll divide our boxes, our whole units into 12ths. 12s work for both of these. So 3/4, when we shaded that, then divided our box into 12 pieces, we had 9 pieces shaded, 9 12s. And here we divided first into 6 parts, shaded 5. And then we split them all in 2 to get our total number of 12, which is 10 out of 12. This gave us a total of 10 plus 9, 19 12ths, and a whole number of 1, 12 12ths, plus 7 12ths. And our last problem and solution, 2/3 plus 3/7. Again, we're going to have to work with a little bit larger number. We can't really break these in. First, we'll take 2/3, and we'll just draw 1 line, 2 lines, and shade 2/3. And on the next box, 3/7, let's just break it into 7 parts. We'll use horizontal lines and shade in 1, 2, 3 rows. Now we need to figure out what we can break this into where the total number of units are equal. And the closest thing will be 3 times 7, 21. So we'll draw our vertical lines and break 2/3 into, we'll draw 6 more lines and give us 7 equal parts going up and down. And for 3/7, we only need to draw 2 vertical lines, but it'll still give us the same amount of equal parts. We now have 21 boxes here, 21 boxes here. We count our shaded boxes, 14 out of 21. And our next unit, it was 9 out of 21. So when we had 14 and 9, 23 out of 21, which is the same as 1 whole. Our whole would be 21 over 21, and that's going to leave us with still 2 out of 21 remaining. So 1 and 221, 2/21 would be our mixed number. I hope you've been able to pick something up from this lesson, and this has helped you understand adding simple fractions where some of them are less than a whole, some of them are maybe greater than 1, and using the area models seems to be one of the better ways until we can work and strengthen ourselves and determine what our denominator should be with maybe not using the area models. And we'll work towards that in coming lessons.